Mamang video walk the queen electric field intensity due to spherical cell tower CD. Electric field between two parallel plates. Electric field intensity between two parallel plates. Suppose let's consider two parallel plates with charge density sigma 1 and sigma 2. Consider region 1. So my plate and calculating she plate and this one of the region 1 Maraxina region 2 also right side region 3 methodology. Region 1, region 2 and region 3. LD. See the level electric field intensity, the level electric field intensity, the level electric field intensity. Put on the see. So you see a plate X caution, see na Y caution. As the quick measurements, direction measurements, see right side is a seen origin and color. Right side is a positive and alone. Left side is a negative and long. And you see sigma is positive, and sigma is the managra Q by E. Karium Q is positive without sigma is positive. Karium Q is negative without sigma is negative in a funganel. Sidle is a positive charge and a kalini. This is the electric field due to displaced D EX. EX direction left side lane samana sonakanda sigma 2 na pira position EY. This is also on left hand side. The chigi mayai left simu yang si sigma 1 na pira position right side lane because it is positive charge. EX sonakanda sina EY. So, man, see the outward positive charge the outward happening in EX on a clear EY should conduct area. Tarasi will let the Granatani sigma 1, sigma 2, sigma 1 is now surface charge density on plate X, sigma 2 is now surface charge density on plate Y. EX in the Grano electric field intensity due to plate X. EY is now electric field intensity due to plate Y. Now, for region 1, total electric field intensity is E1 EX plus EY. EXT when electric field intensity due to infinite plane sigma by twice epsilon naught like already matans level sigma 1 and sigma 1 by twice epsilon naught plus sigma 2 by twice epsilon naught. So get over when I see the origin and color see left hand side that's the direction could negative loading. Right hand side is a positive and loading. See the X axis in color. Let's suppose this is origin and on this side is X dash direction is, and this is positive X. This is positive X. The target is the minus I cap plan. See the minus I cap plan. Jadi sila kena common low here minus 1 by twice epsilon naught common low. Jadi sigma 1 plus sigma 2 harga I cap. This is the electric field intensity in region 1. It was in region 1 minus 1 by twice epsilon naught sigma 1 plus sigma 2 I cap. Similarly, for region 2, region 2 the E2 equal to EX vector plus EY vector, EXD sigma by twice epsilon naught, sigma by epsilon naught. It is in positive direction, so we take it I cap plus EYD. It is in negative x-axis, so sigma, this is for sigma 1 and this is sigma 2 by twice epsilon naught minus I cap, and we put I cap here and minus here, minus I cap. 1 by twice epsilon naught common ore, aduga sigma 1 minus sigma 2 whole I cap. Matokna koi region 2 bi sumana phange, region 2 bi kamana phange 1 by twice epsilon naught sigma 1 minus sigma 2. Region 2 bi region 2 se 1 by twice epsilon naught sigma 1 minus sigma 2 I cap na phange. Region 3 gidi for region 3 parts of region gidi total electric field intensity gidi EX plus EY by superposition principle given, and sigma 1 by twice epsilon naught, it is in positive direction, so I cap plus sigma 2 by twice epsilon naught I cap. This is positive direction to later. Aduna common law is 1 by twice epsilon naught common ore, sigma 1 plus sigma 2 I cap. Region 3 the total electric field intensity in region 3D 1 by twice epsilon naught whole into sigma 1 plus sigma 2. And region 3 the 1 by twice epsilon naught sigma 1 plus sigma 2 I cap. Karigumba when sigma 1 sina sigma ga manaraba, aduga sigma 2 sina minus sigma ga manaraba, IDC plate area se manaraba, as well as aduga magi charge manaraba. So when it's the half of charge, so na kandana plus half of the plus sigma ni lai se the plus half of sidana minus half taraga d kan sina malaya minus sigma oraba magi plate area so sab manaraba e ngata oraba, aduga magi charge density sina sigma medi minus sigma tariya, adudi E1 ji kya ga manar ke siko E1 sida minus 1 by twice epsilon naught sigma 1 ki mota sigma sinjalo minus laan plus ki mota adudi sigma 2 ki mota minus sigma I cap. Therefore, the electric field in region 1 is getting chamana bani khatuna 0 into 1 by twice epsilon naught 0 tar. Electric field in region 1 is 0 tar. Karam kanda when charge densities are equal but opposite in nature. Number 2, the electric field intensity in region 2 set. Since 1 by twice epsilon naught the sigma minus sigma 2 ki mota minus sigma since I get minus plus the plus sigma plus sigma at the twice sigma 1 by twice epsilon naught into twice sigma I get the 2 cancel set karo sigma by epsilon naught I cap. This is the electric field intensity in region 2. Likewise, region 3 the so E3 vector equal to 1 by twice epsilon naught sigma 1 ki mota sigma 2 ki mota minus sigma I cap. equal to 1 by twice epsilon naught. That is minus plus or plus minus minus sigma minus sigma, 0. 0 by cap. And then 0 into something the 0. E 3 0 now sigma and sigma opposite in sign or about electric field in region 1 0 total electric field intensity in region 1 0 total electric field in region 2 is sigma by epsilon naught. Total electric field in region 3 is 0. This is my E1 0 tar. Current condition da E2 is sigma by epsilon naught. E3 is 0 tar. Current condition da sigma and is manaraba. Aduga amana plus or minus or. Sigi matang ko hen capacitance ki matang dam kharakini ai na koi mo na mo khangakini ko matang sidi ko yamna maru topic electric potential as electric potential quite so mind to na charge q go on kan dai si charge q sina p ba side le ba point p go on da p ba si point p se small r distance la ko le ne kala si हम कहेंगे si charge q sina point p si da p ba electric potential hai taragadi kaino matam da infinity dagi unit charge so 1 coulomb charge so pushla matam jida tawriba total work done do unit charge so point p jida pushla pada against the field of this charge q sibo ko na kai ko ba electric potential of charge q at point p na ko am ko hange electric potential at point p hai taragadi unit charge so point p jida pushla matam da tawriba total amount of work done do adu ko na electric potential of charge q at point p na ko adu tiang se kali ko ko ni unit charge mo select bida mana charge to q node ang select tar ga di kai ta ni sidi kai ta ni per unit charge work done per unit charge adu electric potential ki symbol je b na di na to infinity da gi si point ji ta na select ko tam to ri ba work done du da akoina thangjalai ba charge tu na divide to ne ba kan haige electric potential city work done da thangselei charge na divide to ba hai ai kai gum na work done puto kai ta kai tare thangselei charge to ga potential ani product na work done da pi ra ne potential due to a point charge q ja when kamai phangim tam da 1 by 4 pi epsilon naught q by r information important noi ko ai se i ko hum se electric potential chi definition ka hare work done da thangjalei bu charge tu na divide to ko mane hai kare the work done putho ke di thangjalei bu charge ko potential ga ni product na pi re adu electric potential due to a point charge q at distance r kana pi ba 1 by 4 pi epsilon naught q by r na pi re ya ko formula hum ko itoksi force hai ga di thai na ko to ki no 1 by 4 pi epsilon naught q naught divided by r square hai ne addition of q1 q2 by r square hai ne then the electric field intensity hai taraga di 1 by 4 pi epsilon naught q by r square because number 3 da electric potential b hai taraga di 1 by 4 pi epsilon naught q by r. Electric potential has a scalar quantity. It is a scalar quantity. Magi SI unit na SI unit volt ko. SI unit volt B. 마찬가지 electric potential due to an electric dipole. Due to an electric dipole. Very important about derivation. We will see electric dipole amana electric potential. Any point dipole any point that appear like so now when a point P go over lower C points the dipole A B is in a P electric potential. See that when minus Q is Thomas plus Q is Thomas. I think you see the dipole there. When the dipole length 2A later dipole length 2A. See point P is now the center of dipole. Angle theta se mga lay rin kalasi. Si point P is center of dipole lagi. Center of dipole si lagi mase small r la pin kalasi. Adi target yung si dipole si na mamang da ko yung tawag ito na. Si dipole si na point P is the P electric potential have si kaya na tip. Negative charge na si the P potential duga. Positive charge na si the P potential duga. Point P is the P potential duga. Ani gi addition level. Adi si da ko na. R1 na loksilasi sina ko na R2 na loksilasi yan si kana thara ni ko hono b plus minus q charges of the electric dipole twice a dipole length r distance of point P from center of dipole theta angle between distance and then dipole length or dipole moment hai sukai de R1 si kanano distance of point P from minus Q or point A, and R2 si kanano distance of point P from B. Sibuk like that. Electric potential at point P due to dipole. Si kaya mana ni B na thon chala chisa. B equal to B A plus B. Let's call it equation number 1. Now B is the potential due at point P due to A. A then equal charge minus Q is now point P is the P potential. Once I'm among the electric potential due to a point charge 1 by 4 pi epsilon naught. So the label charge the minus Q divided by R. Label distance na R1. Heading P having a core distance. And we can turn down B the learning 1 by 4 pi epsilon naught Q by R2. Sibo lai. Adidi. Koi no si kilo re. Siki OP cover line sida perpendicular ma mixila seba. B dagi amadi A dagi. A dagi perpendicular ma ye ke heta OP cover line sida kilo ne. Ma je koi extend tau la ne. Extend tau la ne. Adagi B dagi ye ke heta na sumaina exil la ne. Sina L na tau la si sina M na thon chala si. Let us draw perpendiculars from A and B on OP. OP. Jadi kai phangya OP da khoi perpendicular ye kre. Perpendicular ye abo matung da khoi ji such that you know such that khoi ji A B is nearly equal to PM or MP 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 and B LP equal to LP ga manana ko luksalini adu taragati yengsi usi cha ko B is get 1 by 4 pi epsilon naught minus Q divided by R1 B sina 1 by 4 pi epsilon naught Q by R2 equation number 2 sina 3 equation number 2 ni sina equation number 3 video 지금 sẽ có A P ra now or again A P have there kana ka mana re siga mana ra banina kan sai M P siga mana ra banina kan ye pada construction ni mutuna ila high ra banina ke dore M P city ka mana tu wai be kana O P plus O M na hai ya adati OB asang di kano ni OM asang di kano samjala siko sina angle theta lakada in particularly opposite angle then OMGD sina hypotenuse ni sina hypotenuse oi ni perpendicular si lai rabanina adi hypotenuse ki OA asang di kano oi A ne small a adi half of dipole length then sidi kya tare cos A hypotenuse cos theta na कोई होना भी थीटा का लेमिन रेडी एक हाइपोटेनस cos थीटा ना लोग तो कोई रिजोल्यूशन ऑफ वेक्टर पांचले नहीं समझ लो बनी फिर AP के संग बड़ी क्या नो AP के संग बड़ी R1 है कोई R1 की वैल्यू पंगे होती कोई ना R plus A cos थीटा ना पंगे नेक्स्ट था BPCD LP के मने है बनी कोई LP in terms of OP तो मुझे आता चाहिए OP minus OL BPC LP mana happening OP minus OL ka adi BP ga sang uli kya no R2 ni adi OP di kya no R ni minus OL di kya no A cos theta si sama na ko theta ka le ni perpendicular sila le si hypotenuse ni adi hypotenuse cos theta hai R2 ki value se koi R minus A cos theta ta adi ti ko yuji yo sida equation number 1 ki mamang ta uri da B ki A amadi B ki value hapchalo adugi matungda R1 amadi R2 ki value hapchala si using equations 2 and 3 in 1 equation 2 और 3 के जो 1 hapchala ka koi uji kya tare total electric potential at point PTU2 dipole है VA की मोटा 1 by 4 pi epsilon naught minus Q divided by R1 plus 1 by 4 pi epsilon naught Q divided by R2 ये कना कमन हो गई नसी Q जो कमन हो गया 1 by 4 pi epsilon naught ये कमन हो गया यदि Q by 4 pi epsilon naught common of 2 ya kanda thing si minus 1 by R1 plus 1 by R2 ja video si tamne ya kanda khang ko ta ba yemo adi si minus sin sona kana set kharji Q by 4 pi epsilon naught 1 by R2 minus 1 by R1 CG LCM to selasi LCM to ya termina product to run hai product to sela kana ko ji kya tare R1 R2 sidena R1 minus R2 ये मान के लो हफ्सला से कोई B की वैल्यू जी kya tare R1 की वैल्यू जी हफ्सलो R2 की वैल्यू जी हफ्सन बिरो Q by 4 pi epsilon naught R1 की वैल्यू दी R plus A cos theta minus of R2 की वैल्यू दी R minus A cos theta whole divided by R1d R minus A cos theta equal to R plus A cos theta Q by 4 pi epsilon naught. 자, kitang samge yengsi bracket sa hange mamang da minus lai taragadi manung do yaw sign hingi lo change to na have ni adi minus R la sida plus la ni de minus R to sigi minus R siga kathana ni sigi plus to ka the one sida plus A cos theta ta ni sida plus A cos theta am jare adi 2 times A cos theta sida makha da mu yengasi A minus B A plus B adi A square minus B square B di A cos theta ni na A cos theta whole square simplify to silakan adi Q je menu sam grasi 1 by 4 pi epsilon naught 2AQ cos theta divided by R square minus A square cos square theta. Sida mu yengsi ako yung makada le batang R square minus A square cos square theta sida when R is very much greater than twice A hadi dipole angle yam chaw gi condition da hai ani dipole angle yam chaw gi condition da se R square minus A square cos square theta se is equal to R square hadi on A se am pick ni adi cos theta si mai value si kadi ga usale minus 1 agina 1 bao chale ba magi value si adi tar ga di minus 1 ni 1 usale 1 oi tar ga ma 1 ta de ni cos 0 oi tar ga di 1 ta de ni 1 ai ti ga na minus 1 ta de ni adi marak to ta de di 1 de ni pick ba value ni 1 de ni value si square ga masana ke do wa ya ne pick ba value mo gi square ga ani gi product si he na pick ne ba adi ma se ko na R square ne na losin ya de therefore B is get that 1 by 4 pi epsilon naught 2AQ di kaino kogi dipole moment P to ni P cos theta divided by R square and this is the electric potential at point P. This is the electric potential at point P due to dipole AB. Dipole AB at a distance R from the center making an angle theta. Theta is not way to go. You can see, specific case and case number one. When theta equal to 0 degree. Theta is 0 degree way by the kaino. Theta is 0 degree way the whole degree of tie. So when the dipole point P is my two of tie. To the Axial is in the level. Theta is 0 degree height the axial point happening. Where point P is axial point axial is in the level happening. The potential B is get 1 by 4 pi epsilon naught P cos 0 degree divided by R square. The cos 0 di kano 1 I don't know 1 by 4 pi epsilon naught P divided by R square. Case number 1 is the case number 2. Case number 2. When theta equal to 90 degree. Theta is 90 degree way by the kaino. Point P is 90 degree form to the center sida. Masakara tare. Equatorial point tare. Equatorial region tare. Dipole sigi. Equatorial point has to the region has B is get 1 by 4 pi epsilon naught P cos 90 degree divided by R square. Sila katang samge. B is cos 90 is 0. 0 into P is 0. 0 divided by R square is 0. 0 into 1 by 4 pi epsilon is 0. Electric potential at equatorial region is 0 tare. Any question ID axial region da electric potential ki formula derive to higher so samana wa sibo derive to ka singkatang hapsen bi lo equatorial point da or equatorial region da ꯑꯗꯨꯒ electric potential derive ꯇꯧ ꯍꯥꯏꯔꯒꯁꯨ ꯁꯤꯕꯨ ꯇꯧꯔꯒ ꯁꯤꯒꯤ ꯄꯣꯏꯟꯠꯁꯤꯗ ꯍꯥꯞꯆꯤꯟꯕꯤꯔ ꯂꯣꯏꯔꯦ ꯑꯗꯨꯅ ꯀꯃꯟ ꯑꯣꯏꯅꯕ ꯑꯃꯈꯛꯇꯪ derive ꯇꯧꯔꯒ ꯌꯥꯕꯁꯦ ꯁꯨꯃꯥꯏꯅ ꯂꯥꯏꯅ ꯁꯥꯗꯣꯛꯄꯅꯤꯅ